Today we are starting Unit 3, so turn to page 1. We are going to learn how to name polynomials. Now, polynomials have two names just like we do. Well, actually, we kind of have three because the middle, okay? Okay, and we're going to learn how to name these polynomials. Every single problem on this page is a polynomial. But because of certain characteristics, they can be named more specifically. First, by their degree. Okay, degree has to do with its highest exponent. Okay, the degree of the polynomial is determined by the highest exponent. So let's look at number 1. Does it have an exponent? No, you will not have an exponent if you do not have a variable. Okay, now, are you able to change this negative 10 to a different number? No. There's no way we can just change a number to another number. What do we call it when something stays the same? Constant. Okay, so this is known as a constant polynomial. Okay, but just write constant because it can be named something even more specific than polynomial, and we'll get to that in a few minutes. Okay, so number 2, for the same reasons, it's also constant. It has no variable, so no exponent. You can never change a 6 to anything but a 6. It remains the same. It remains constant. Okay, but number 3 is no longer a constant because it has a variable, and so I could change that negative 8. Say I wanted the negative 8 to become a negative 16, I would just input a 2 for the m. Negative 8 times 2 is negative 16. Okay, it's a variable because it will vary according to what you plug into it. Now, is this variable raised to an exponent? What is it when there's no visible exponent? An understood 1. Anytime you have a variable, there is an understood exponent. If it's not there, it's a 1. If it is there, you just look at it like 2, 3, 4, and so on. Okay, but if there's a variable and you don't see an exponent, it's 1. Now, look at this. Say that instead of m, I change that to an x, so negative 8x. And then say I graph it. Let me delete everything. Second plus 7, 1, 2. Okay, so say I graph it. If it will graph. Okay, and then I already forgot the problem. Negative 8x. Because really, does it matter what letter you use? No, variables are variables. It doesn't really matter what letter you use. So I'm going to type it in as negative 8x. Okay, what is it a graph of? A line. Yeah, that's a line, which is linear. And remember on the last test, we talked about functions that were raised to the first power are linear functions. Okay, same thing with number 4. That m is raised to the first power, so this is a linear polynomial. Because watch, if I, instead of m, if I just call that an x, and I graph it, y equals, it's evidently having problems. But if I were to graph y equals x, there it is. Think about it. In front of this x, isn't there an understood 1? And out here in the b place of y equals mx plus b, isn't there a plus 0? So if I graph it, it forms a line that starts at 0 and then goes up 1 over 1, up 1 over 1. Okay, so it's linear. Now, number 5. Let's see what happens if I graph that. Negative 6x squared. It makes a U-shaped graph called a parabola. Now, why is that parabola upside down? Because it's negative. And what do we call parabolas? What kind of function? Quadratic. When its highest exponent is a 2, it's degree 2, which is quadratic. Okay, so for the same reason, 6, which is just x squared, is also quadratic because its highest exponent is a 2, and a degree 2 polynomial is known as quadratic. Right. So in the next problem, 3n cubed, if you graph that, y equals 3n cubed, but I'm not using n, I'm using x instead, but that doesn't make a difference. Does that make a parabola? No. That is what kind of function? A cubic. Okay, the highest exponent is a 3, and degree 3 polynomials are cubic. Okay, we talked about that too on the most recent unit. Number 8 is also cubic. Now, all of these words that we've covered so far should not be new to your math vocabulary. Okay, you've been hearing these words for many years. But in 9th grade, when I was teaching naming polynomials, I taught this to y'all in 9th grade if you had me, whenever you got to a polynomial that was degree 4, meaning its highest exponent was 4, I allowed my students to just write out degree 4. But it also has a special name. Its special name is quartic. Okay, well, like 6, let's change that to 6x to the 4th and see what kind of graph it would make. Y equals 6x to the 4th. Okay, now look. Number 10 is also quartic because its highest exponent is a 4. And when the highest exponent is 4, it's degree 4, which is quartic. Okay, number 11. The highest exponent in number 11's polynomial is 5. Any idea what a degree 5 polynomial might be called? What? Almost. That's a good guess. What is it called when you're having 5 babies at the same time?
I don't know.
Y'all don't know?
No.
Quintuplets. Okay, this is called quintic. Okay, number 12 is also quintic because it's degree 5. The highest exponent is 5.
Oh, it's not that.
Alright, number 13. 8n plus 2. This time we have more than one term. We have 8n and we have the 2. What exponents do we have? Right, this n is raised to the first power. This 2 is a constant. So what's your highest exponent in this polynomial? 1. So degree 1 polynomials are called linear. And think about it, guys. Doesn't that look awfully familiar? Y equals mx plus b form. The 8 would be the slope. The 2 would be the y-intercept. It would make the line. So started at 2 and then what? Up 8 over 1, up 8 over 1. Okay, same thing with number 14. Negative 9b is to the first power. 9 is a constant, so no exponent. So since the highest exponent is 1, it's linear. Number 15, what's the highest exponent? 2, making it quadratic.
Are you just worried about the exponents?
Yep. To name the polynomial by its degree, you're looking for the highest exponent. What about number 16? What's the highest exponent? 2. So it's quadratic. Its highest exponent is 2. Even though this is to the first power, we only care about the highest exponent when deciding
So
the
you don't
degree.
add them?
So,
Okay.
okay, number 7. Cubic. Number 18. Cubic as well. Because even though they have multiple exponents, the highest one is 3. Number 19. Quartic. Number 20. Quintic. Number 21. Okay, just like freshman year we stopped at cubic, we're going to start with quintic today and just call this degree 6.
It doesn't have
It does. It's not big, it's just, it's just sextic. And then 7 is septic and octic and nonic.
Yeah.
So we're just going to stop with the special names at degree 5.
8 is octave.
8 is octic. 9 is nonic. 10 is...
It's
exactly.
It's like chemistry.
100, degree 100 is hectic. It's kind of funny, isn't it? It would be a hectic polynomial.
Oh my gosh.
Okay, so now what is 22?
Degree 6.
Degree 6. Number 23. Degree 6. 24.
Quintic.
Quintic. Okay, we're not done. Don't turn over the page. Remember, they have two names. Their first name comes from their degree, their highest exponent. Their second name comes from their number of terms. All of these are classified as polynomials, but a polynomial that only has one term is known as a monomial. Okay, so number 2, that's only one term, so that's also a monomial. What about number 3? It's still a monomial. It's okay. I know we have a negative a and an m, but they're a product. Okay, they're together, so it's still one term. Like you could have, let me show you something. You could have something like x cubed y squared z. That's still a monomial because all of them are a product. Now, to find the degree of a monomial, you add up their exponents. So like 3 plus 2 plus 1, this would be degree 6. Okay, but that's only for monomials that have multiple exponents. Okay? All right. Now, if I were to take this and then add 2, now I have a binomial because I have two different terms. The reason I know they're two different terms is because they're separated by the plus sign. So when we look at our paper, we can see that all of these are monomial until you get to what number? 13. Okay, so all of these are monomial until we get to 13. Okay, and do you see the difference between all of those and 13? 13, you have an 8n plus 2. That plus is separating two different terms. 8n is one term, 2 is another term. So what do you think we call it when there's two terms? Binomial. Okay, because bi means two. Kind of like a bicycle has two wheels. Okay, so number 14 is also a binomial. There's negative 9b is the first term, and that positive 9 is the second term. 15 and 16 are both binomials. What about number 17? How many terms do we have in 17? 3. Negative 3p cubed is a term, negative 5p squared, and positive 1p. So this is a trinomial. As is 18 and 19. What about number 20? Binomial. Okay, 21. Trinomial. What about 22? It's actually just a polynomial with 4 terms. (23) is also a polynomial with 4 terms. And what about 24? A polynomial with 5 terms, because there's 1, 2, 3, 4, 5 terms. Okay, now you can flip to the next page, but don't get started. We've got a couple of things to still talk about. Okay, Okay, the next page, I want you to read out problem 16 to me. Whoa. Negative 7x Okay, so one thing that we were supposed to learn today is how to name a polynomial, which we just did. We learned how to name it by its degree, which is its highest exponent, and by how many terms it had. The second thing we need to learn is how to write a polynomial in standard form, which most of you probably already know how to do. What do I mean when I say write it in standard form? The order of the exponents. So what term would come first? Right, this positive 9x to the fifth would need to come first because 5 is the largest exponent. So what would come next?
Well, 7x.
Minus 2x cubed is the next largest exponent. Then, okay, now that it's in standard form, what is the name of it? Quintic polynomial with 4 terms. Okay, what is the leading coefficient? No, 5 is an exponent. What are coefficients? Aren't they these numbers beside the variables? Okay, like if I say I just change this problem up and I add in a 2 at the end, this 2 is known as a what? A constant. Okay, this is a constant because it doesn't have a variable. But numbers with variables are called coefficients. So now that it's in standard form, what's the leading coefficient? The first coefficient of the problem. 9 would be the leading coefficient. Okay, so like if you were just looking at this problem and I said, what's the leading coefficient? And you said negative 7 because it's the front, it's the leader, you'd be wrong because it's not in standard form. To be able to identify the leading coefficient, it has to be in standard form. Does that make sense? I just added it in to show you that that's a constant and these are coefficients. Coefficients are numbers with variables. Constant is the number without the variable. I just added in the 2. It's not really part of the problem.
No, I was talking about, you probably a quintic is the first thing.
Right, because it's degree 5. And yeah, this wasn't really there. I just added it in to show you the difference between constants and coefficients. Okay, so now what you need to do is you need to go back to the packet and work all of these problems. Okay?